Hi, welcome to Kente Code AI, another edition of our lecture series on Python and SQL foundations. So far, we have gone through a lot of stuff. We've reached object-oriented programming data structures. We have covered that, and we have started reading test files in our last lecture. So today, we are going to focus on two important libraries in Python, that is Pandas and NumPy. So without much ado, let's get into it. Okay, so we are going to start with Pandas first, NumPy first, then we'll go to Pandas. So NumPy basically is if you come from any other programming background that is an array in Python. So what we want to do is we want to learn how to create NumPy arrays and perform analysis with the NumPy array. Then quickly we go to the main Pandas, how to use Pandas for data analysis, filtering data is going to be the most important tool that we are going to be using to handle data training, analysis, and all that stuff is going to be done with Pandas. So that's the main library in Python for that kind of work. So let's start with NumPy. So NumPy is numerical Python. That's the name. It's a library for numerical computing in Python, and it provides support for large multidimensional arrays and metrics, collection of other functions, data functions. You can find mean, median of arrays. So quickly, if you want to perform very fast operations, Pandas NumPy is the way to go. So we learn list. So list where you have the curly bracket, the square bracket with the items in it. Performance for a list is lower than performance for arrays. NumPy is specifically made to make that work very fast. So we want to focus on that work for Pandas. So for NumPy, so if you don't have NumPy, you have to install the library. So to install the library, you just say pip install NumPy. Okay, so pip install NumPy here at the bottom will install the NumPy library. So in this lecture, for example, since we are going to be doing NumPy and then Pandas, you make sure I'm using a virtual environment, so my virtual environment is activated. So if I want to install both NumPy and then Pandas, so I just say pip install NumPy, then I say Pandas. Okay, two of them. So I'm installing those two libraries. So, but what I did earlier was I created a requirement file that has, normally that's how I have to put a requirement file that have all the things that I need. I need Pandas, NumPy. Another library I'm going to be teaching later is request. So if I have the libraries in this file already, then I do not have to directly install just one by one, like this, but pip install NumPy and then Pandas. I can easily say pip install, then I say minus R, then I say requirements.txt. Where requirement.txt is the file that I put all the libraries inside. So that is another way to install multiple libraries. Normally, that's how you create a project. You have a requirement file that has all your libraries in it, like this, and then you use you can use pip to install everything that is in the requirement by saying pip install minus R for the requirement. There's a requirement.txt. Whatever you name this file, you can, yeah, that's the name you're going to give here, and then it will install all the list of libraries that you have in the requirements file. Okay, and you can go back. This I digress a little bit, but you can see already the libraries that you have on your say pip list. If you say pip list, it will show you all the things that you already have installed. You see, if I say pip list, see, it show me all the libraries that I have. So if you want to install a particular library and you don't know if it's already on your machine, you can just say pip list. It will show you all the libraries that you already have installed on your system, so that okay, you already have it. So that is a quick one. And also a quick thing I wanted to say: if, for example, you need to get all these libraries into a file that you can use, you can just say pip freeze. Say pip freeze. Okay. This is not the point for this guy, but this is also good something. Freeze, then you do that, you pipe it to a file. Let's say I pipe it to a file called rec.txt. This will take all the things that I've installed and put it into this file rec.txt. Right. So if I run this, I run this now, it's going to create a new file called rec.txt. So rec.txt. When I open it up here, I can see, you see this file. You have all these files. So in case you are just installing things and you are not installing any virtual environment, and all of a sudden you need to get all the items that you actually install in your on your machine, this is helpful to just say pip freeze and put it into the file, and then this file then you can share with other people. If they need to run your program, they can just go and say pip install -l, and then give the name of this file, and then they'll be able to install all those things on their system. And also, if you want to remove all this stuff, you just say pip uninstall. Okay, you say pip uninstall -r, right? Pip uninstall -r, the rec.txt --y. This will uninstall everything that is in this file, and silently -y means yes, because when you uninstall it will be asking you if you want to uninstall something or not, and then the -r means yes, uninstall it will uninstall everything. Okay, that is a quick digression from there on how to manage packages here, but our main topic today, Panda and NumPy. So let's go. As we said, NumPy basically. So you install the NumPy. You say pip install NumPy. Once you have it ready, then you can use it. Okay. So this is the NumPy library. If this is the standard regular way to install, is you after install you call it import NumPy as np. This is the way everybody almost. This is the industry standard way of importing it. You say import it as np. Then np becomes your reference, the alias to NumPy, and then you can use the np in whatever you are doing. Right? So now, if I want to create an array, so like this is a list, right? This is a list. We learn a list of numbers 1, 2, 3, 4, 5, and I want to convert that list into an array. Right? So so this is a new array. I'm saying I'm using the word. It's going to be the np, the NumPy -array. Okay, then you give the curly bracket around it, you see, and then you supply what you want to use for creating the array. So let's run this code. So when you see this code run, you see that this is the array. It shows like this: 1, 2, 3, 4, 5. That's the array. Okay, and the type we learned type in variables. So the type of this particular object AR is mp.nd array. So number is for dimensional, is a nd array. Like you can have one dimension, two dimension. For example, this is just one dimension. We go into detail what are the nd dimensions mean in the future. So why do we have to use NumPy instead of just using list? We say it's for performance. The performance is very good for NumPy, and the convenience, because it has a lot of mathematical ways that already inbuilt over there that you can use to process those information. So because of that, NumPy has a better performance, so you can use it for your work. Convenience, performance, and foundations. It is the foundation for a lot of data science libraries like Pandas, scikit-learn, and SciPy. NumPy is used for that. Okay. Now we see how we can create the arrays. So this is two arrays I'm creating, and this is array 1. Yeah, 10, 2, and then this is array 2. So yeah, these are all. This is array 1. So you see this here, I'm using a list to create the arrays 10, 20, 30. That is a list. Here I'm using what? A tuple. So you can use a list or a tuple. So that's a tuple. We learned tuples earlier on the data structures. So yeah, but then that forms gives us this array 4, 5, 6. So a list for first one and a tuple for this one. Okay. as I said, there are built-in functions already in NumPy to get different type of arrays. Okay, so there's a built-in function zeros, okay, ones, arrange, line space. You don't have to memorize these things. They are there, but zeros basically you want to create array filled with zeros. Okay, you want to create arrays filled with zeros, and then for example, right? So this is a 2 and a 4. That is the dimension of the array you want to create. So the to give the dimension, the first one is the rows, and then second one is, let me show you something over here. So if you have an array, okay, you have an array, it's like this. Okay, so this is an array. An array, okay, you have 1, 2, 3. Then let's say we have a 4, 5, 6. Okay, so these are the rows. This is the row. This level is the rows, and these are the columns. Okay, okay. And when you, this array is 2 rows, right? 1, 2. So you say 2, and then the columns 1, 2, 3. So 2 by 3. Okay, 2 rows by 3 column. That's how you call array. 2 by 3. Okay, that's two-dimensional array. You see, so this array has 2 rows, 3 columns. Okay, that's you can say it. Okay, and this is a 2 by, is it, this is how it's said here, 2 by 3 array of zeros. When you are calling the zeros function, you have to supply how you want the array to look like. If you want it a 2 by 3 array, then you supply that information in the tuple here. Okay, if you want just one, that is it. So this tuple is saying I want 2 rows, 3 columns. That's how you read it. This is a tuple. All right, if I just want one long horizontal array, I give only one value, 5. That 5 will be only one line, 1, 2, 3, 4, 5. You want to have one, because you're specifying only one row. So this is MP. This is MP dot one. This is MP dot zero to give you all zeros. MP dot ones give you everything. So the first one, MP dot zeros, 2, 3, 2 rows, 1, 2 rows, 3 columns. So 1, 2, 3. Okay, 1, 2, 3. So that's MP dot zeros, supplies you all that information. Now MP dot ones, 5 ones, because you say it give you only one dimension, 5. 1D, that's 1D array of 1. So you see, it give you 1 up to 1, 2, 3, 4, 5. Okay, arrange is different. Arrange, what you are specifying arrange is, this is the beginning. You can specify the beginning only. Then this is the end of the array, and this is the step you are going to take. But you cannot reach the end. Okay, you cannot, the number that is here, the stop, your array have to stop short of that. So for example, if I say 0, 10, 2, it means that I'm starting from 0. The steps I'm taking is 2. So I start 0, the next number will be 2. The next number will be 4, the next will be 6, and then the next will be 8. But then I cannot reach the number that is put over here. So I end up on 8, because the next step 2 will reach 10. So I have to. Line space is just you give number in a range. You see, 0 to 1. Okay, you are giving a number from 0 to 1. Numbers within 0 and 1. That's where you want it. And how many of them do you want? 5. So you say from 0 to 1. How many numbers you want? So this is 0, 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5. Right? 5. Yes. So from 0 to 1, I want 5 numbers. So these numbers 0 to 1 inclusive, and I want 5 numbers. That's what this means. So yeah, those are just some functions, built-in functions to know how to use NumPy. And the arrays have attributes. They have shape, they have endian, they have size, the data type. You can get all that information. So look at this. I have the array np.array. Look at this carefully. This is one list, right? And then this is another list. Okay. If I give these 2 lists to this array, to the function array, it's going to put this and then stack this below it. So look at this. This is this. The first list is here. The second list come, and all of them are in. You see the bracket. You try to see this bracket over here. Yeah. So it start both. What the first one come and the second one come. So when you give multiple ones, it will stack it on top of them. Okay. It will start one, two. That's it. Okay. Okay. So if I have this particular array like this, right? This is the final array it generates from that, right? What is the shape? If I want to see what is the shape, is called the array dot shape. Okay, the array dot shape, and the shape, two rows, three columns, right? Two rows. This is the first row. This is the second row. Three columns. So one, two, three. So that's what shape gives you. Okay, that's when you call the function the object dot shape. That's what it's going to give you. It's going to give you the shape like this, and then the type, the data type of the array. That is, if all the elements are the same type, it will give you that type, right? But if it is not all of the same type, like if you have a character here or character somewhere here and the numbers, it will give you the type as just object. But if it is all of the same type, like string, it will say is string. If it is all the same type of integer, it will say int 64. That's how it is. Okay, now there is something also called that's the data type. Let's see another function method is ending. Is you see the dimension the you see the D, that 1D, 2D, 3D. What is it? How to get that? It's a two-dimensional array. It's ending. That's how you find it. The array dot ending. The two dimension means that it has rows and columns. Okay, rows and columns. That's two dimensions. A row. A series is one row, or it's a series, but when you have a rows and column, that's multiple series, you have a dimension of rows and column, that is two-dimensional array. Okay. Now, what is the array dot size? The size is the number of elements in the array. Okay. So the number of element 1, 2, 3, 4, 5, 6, that will give you the size. So here's the 6. Yeah, so that's the basic information on the NumPy array and know how to create it. Now we learn slicing and indexing in a list. It applies the same to NumPy. So the list is the same way the list is behaving is the same way NumPy is behaving, except list is just one dimension, right? It's just one dimensional thing, and you can slice it. But NumPy now have multiple dimensions, so slicing it can be a little bit. So, for example, right, this is np.arrange 10. So right now we have arrange. Remember we say arrange. It will take. You can take three numbers like 10, 0, 10, 2. Okay. The first number is the start, and then the second one is the end, and then two. The last one is the step. If you are giving only the first number here, it means that that is the stop. You can the stop. This is where you are stopping, and you are starting from zero automatic because you're not giving any start. You are starting from zero. Default, the step, it will be one by default. Okay, so that's what that means. Okay, that's what that means. So the array equals np.arrange 10, right? This one. Array equals the array is just the array name, the array I'm different. It's np.arrange 10 means that okay, once things from 0 to 9, the 10 is the stop because I cannot go into the stop that is given. It has to be always the step cannot reach that. It has to be below. So I'll give numbers 1 to 9 over here. That's what this means. Okay, now this is the original array, and if I want to get the element as index 3, remember when we are doing list, when we call the index, we will go up to one number below the name that is given here in the index form. So if I want to get the element, okay, at index 3, so I have here, that's index 3, that's what this means. So I have to start from, this is the first index, 0, 1, 2, 3. So what is that? Number 3. So the element at index 3 is 3. You see that? Okay. Now this is a multi-dimensional array. It's a two dimension. So Oh no, this is just a single dimension. Yeah, this is one dimension array. Now remember we do the sliding in the list. The same applied in array. So we say we are starting from 2 to 7. We are starting from index 2 to index 7. So in this array, index 2 is 0, 1, 2. We start here. So we start from 2. And then the last index is 7. Remember, we cannot reach the last index itself. So we have to start from 0 up to 6, right? So we start 0, 0, 1, 2, 3, 4, 5, 6. So we end up on 6. So our number will be coming from 2, 3, 4, 5, 6. That will be our slice when we slice it slightly. So slicing arrays, slicing lists, when it comes to single dimension, is the same concept. Okay. All right. Now let's look at the multi-dimensional array. So this is the second one. See, mp.array, we have the first array here. Okay. The first list there and the second list here. So it will stack them, put this and then put this under it. That's so this is what we have here. We have here and then we have here. Okay. So let's take this over here and see how it looks like. See here. Okay, let's do it with this. Yeah. Let's say it's the same number. If 1, 2, 3, that's the first one, and then 4, 5, 6, right? And look at what we are looking for over here. We want to get the index matrix at 1. When you say 1, when they give you only one when it's a multidimensional array and they give you only one value, so it's just referring to the first row. It's just referring to the index in the row column. So the row column, when it's only one value given in the slice, then it's referring to only the row. So row 1 means this is index 0 and then this is index 1. So when I say matrix at 1, I'm looking for this value. So that is 40, 50, 60. So this is one. But if you give it two values, because it's multidimensional, right? If two values, the first one will refer to the rows, the second one will refer to the columns, right? So this is row 1, which is 0, 1. It will come to this place, right? Now, once I'm in this one, it says column 2. So this is the first column. This is the second column. Let's do it on this one. This will show better. Okay. So this is the first. This is row 0. Okay. This is 0, row 0, and this is row 1. This is column 0, column 1, and then column 2. All right. This is it. So if it says here in this that we are looking for 1, 2 in from here, 1, 2 would that mean that we are moving from, we are now in this row 1, and then column 2 will be 0, 1. So this number, okay, that is 5. In that perspective, that will be 5, because we are on 0, 1. This is what we are going to point you to this, and then we have a 0, 1 column is pointing to this particular value. So here, if you look in here, that's what it say. This is 1, 2. So we are in a 0, 1. That will be here, and the column 2 will be 50. Will be a column 2, 0, 1, 2. That's the last one. Yeah, column is 2. Yeah, column is 2. So it's 60. Okay, so that's why this gave us 60. Okay, you can go into those operations, but those are just how they work. Okay, so so now let's look at another operation. NumPy supports element-wise operations, broadcasting and many mathematical functions. We will not go deep into the mathematics, but it's good to know generally how these things are. So for example, right, I have the array. This is the first array A, 1, 2, 3, and then the second one is 10, 20, 30. If I'm doing operation and I want to add these two arrays, it's going to be an element-wise. So look at this. Okay, have 1, 2, 3. So this is the array for A. This is array A, right? This 1, 2, 3, and then B, 10, 30, right? Now, if I say I want to get A plus B, A plus B is going to be element wise. It means that 1 will add to 10, we get 11. 2 will add to 20, that is 22. 3 will add to 30, that is 33. That is an element wise operation for arrays. If I say A times B is going to be the same thing, 1 times 10, yeah, so you get an idea. So that's what it is. And if this one is square, is the same thing. It's raising them to the power 2. So if I say A, no, this is A raised to the power 2 means that each value of A will be raised to the power 2. 1 will be 1, 2 will be 4, 3 will be 9. So that's how it's element wise. That is element wise operation. That's how arrays work. Now, broadcasting is a term in array. You can be able to expand an array with a short. So look at this array. A has 1, 2, 3. Okay. Look at C. C has this is one dimensional array, right? Because it's one list with 1, 2, 3. That's all it is. But look at C. It has 1. This is first list, right? You see, this is a list of 1. This is a list of 2, and this is a list of 3. So when it comes, it's going to stack these. This will come under this, and this will come under this. So this is C, is just one long list. You see, I mean A is just 1, 2, 3. That's it. But look at C, is 1, 2, 3. They are stacked on each other. Okay, it's one long series. Okay, that's 3 rows. 3 rows, 1 column. 3 by 1. 3 rows. The row is 3, 1, 2, 3 rows, and then column 1. 3 by 1 array. Okay. Now look at this. Okay, broadcasting is the process where you say let's say I say C. This C is here plus A. The new array is going to all these numbers to each. See this one, 1, 2, 3 is going to add it 1, 2, 3 to each of these values and form a new array. So look at it. We have 1, 2, 3 here. It will always reflect to the 1. See, three rows now. 2, 2, 3, 4 is 1, 2, 3. It will take 1, add it to each of them. You see, 2, 3, 4. Now that's 1 row. Then it will take 2, add it to each of them. So we have 3, 4, 5. Then to take the 3 and add it to that, so that you see that we will now maintain a bigger dimension. It broadcasted the smaller one was to maintain a longer, bigger dimension. Now this is a 3 by 3, 3 rows, 3 columns. This is a 3 by 3. It has expanded it, but in the beginning it was just 1 dimension array and then 3 by 1 dimension. So you broadcast it by expanding using the values to multiply across it. Okay. We have the C. This is the C. So whatever the C, the main one, which is like this, right? Which is like this, is try to expand across these ones. Is added across each of them. Each of those ones have become element on their own with the C added on top of them to form a bigger and new array. So broadcasting is something in array. Most of this is good when we are doing machine learning from scratch. You know how to manipulate these systems. We learn those things when we are actually doing machine learning from scratch. You will be able to do those. Those functions are good to understand. But in this, of course, we are not doing those things. But it's just good to know that is the base for building most of the libraries in machine learning, in data analysis. Those are some of the concepts. Okay. Now, let's quickly see. I say arrays, NumPy arrays, they have inbuilt mathematical functions. One of them mean. So if I have 20, 30, this as an array, yeah, I want to find the mean, I just use np.mean. It's inbuilt function of B. And then you get the mean. So it's very fast. That's the advantage. It's really fast. It performs really well. And I want to find the standard deviation, np.std. You will be able to get it. So you see np.mean, mean of this, the standard deviation. Okay, that is functions. You can just, you don't need to keep this in mind, but you know that those functions are there. They can quickly use. You can quickly use them to get the information. You can also reshape the array. You see, reshape means that you change the shape. Yeah. So for example, this is the array. You have this array. First array np.6.arrange 6 will give you 0 up to 5. Now you want to reshape it to a 2 by 3. 2 column, 2 rows, three columns. So you need two rows and three columns. So you fill the columns with the values first. Since I need three columns here, I will start and fill one, two, three. So I fill three columns at the top, and then I go to the second row, and I fill the rest, three, four, five on this, excuse me, on the second row. So I reshape this one-dimensional array into a two-dimensional array. That's reshaping, good for stacking arrays. So there is a vertical stacking and then a horizontal stacking. Stacking just means that arrays on top of each other or make it horizontal. So if I have one, two, three, okay, and I have one array, this is array one, and I have another array 4, 5, 6, and I say I want to do vertical stacking, I'll just take this array and put the other one under it, so it becomes vertically stacked, the first one and then the second one. If I want to do horizontal stacking, then I'm going to put this one first and then put this one, then it will become one array by the side, so it become one array like this. So that is horizontal stacking. These are good when you are actually learning. There are some things that are there when we are doing calculations that you can use those functions to actually quickly get it. You can also filter the array by using a mask. Okay, for example, like 10, 15, 7. This is the array. Okay, that's the array 10, 15, 17. Now, if I want to mask and find the value for a particular, if I 10 greater than the array greater than 10 means that I will scan the value in all the list in here and see which of them satisfy this condition. If it satisfy the condition, I'll mark that location as true. If it doesn't satisfy the condition, I'll mark that index as false. And once I have that mask, we call it a mask. When you apply it to the array, it will take and give you only the numbers that satisfy the condition. So look at this. This is the mask. We call it the mask. Okay, you create a mask. Okay, and then false because what? 10 is not greater than 10, so it's false. Then here 15 true because true because yeah 15 is greater than 10. Yeah, that's true. So you create that mask, and then when you put the mask back into the array, it will now say, hey, array, give me only the positions that is true. See, so only the positions that is true, it is going to be 15 and then 22. So that's why you give the filtered array to be like this. Okay, all right. That's one thing. Okay, and also if when we are doing machine learning processes or AI research and that stuff, there's something called we call seed. We want to reproduce whatever we are doing. So the seed is something we set beginning of our workflow, so that somebody can also set the same seed and try to reproduce the results that. I get when I did my research. So NumPy provide that kind of capability. So the tool is called np.random.seed at 42. So it sees at 42. So if somebody want to repeat your research and then get the same result, they also have to set that number when they start running the machine. The seed is something that happens in the machine. The machine automatically generates a number that is set, so that random generations that happen will always be based on the starting seed. So that if somebody wants to also repeat the same thing, they have to set the same number in the machine in order to generate the same random numbers if they want to. Yeah, and there are different use cases for this, and you can use the numpy np.random to do different type of so that's you can generate random number. You see 3 rows, 2 so this is for the seeding. Okay, this is for reproducibility. This is what you are trying to generate random numbers for an array of 3 rows and 2 columns. Okay, yeah, so and then this one is what this integers. If you want to generate you want integers generated randomly, you can say from between 0 and 1 and the size of 5. You want 5 random integers between 0 to 10. It always the last one does not include, that's just how it is. So you can see those ones here, random numbers we generated. This one is not something you see. Okay, you don't see. This is something that is seeded in the machine. It's not something that you can see. Okay, and then when you do the seed and whatever you generate, the seed will provide that number out of it. You see, when I run this, Okay, okay. If you look at something, you see, because I see this at this number, all the random numbers I'm generating here will be the same number, okay? Will be the same number no matter how many times I run this process. If you look at this, this is the same number I'm generating because it's not random. Actually, the machine actually have once it seed it, it's the seeding get you. If I run this 10 million times, I'm going to get the same random numbers generated. So it's actually when it comes to computer science that behind the computer is not random actually because when you set a location, you get the same number for anytime you ask for random. Okay. And NumPy also provide operations for linear operation like matrix. You can do matrix operations. We don't have to get into this. If you want to multiply, let's say this first array, yeah, by the second array, matrix multiplication. If you just want to do that, say np dot dot. That's the function and the method, and the A and B. It will provide you the matrix multiplication. To transpose, if you want to transpose an array, is you have A and you want to transpose this, is just A dot T. Transpose simply just means this. So for example, right, if you have this array like this, if you have array 1, 2, 3, then I have 4, 5, 6. Transpose meaning that this transpose A, this is the array A. This is your array A. A dot T in the mathematics, A dot T, the transpose, is just you take all the first row, take the first row here and write it 1, 2, 3. Okay, then take the second row here and write it 4, 5, 6. This is what we call transpose in math. Okay, all right. So we don't need the math. So, but that's how. Now there are some things eigenvalues and eigenvectors. We are not going into that details, but you can find the eigenvalues by using np linear_eag, and it gives you two values for this particular eigenvalues are good when you are doing machine learning. So it gives you those values. You just know that those are there. Right. After doing all the array, you have the array. NumPy provide you an option to save it. It's mp.save. Then you can save your array to a file. Okay, just mp.save. And if you have the array in a file you want to load it, it has the option mp.load, and then it will be able to load the array. And then you can see the array back, like that. So that is NumPy, because NumPy is important because it's most of them is behind the scene for most of the operations, and it's actually the basis for pandas. So before we get into pandas, which is next, we just want to know what NumPy is, and then we get into pandas. Pandas is the main thing to use most of the time. We're going to be using this thing. So pandas, as I said, is one of the most powerful popular libraries in Python for doing data analysis and then manipulation. You are going to use pandas to clean data, to analyze, to do a lot of work in this Python and SQL foundations course going forward. So there are things that we need to just get out of the way. So we need to understand most important things are the series and data frame. Data frame is the main one we are going to use for understanding everything. But a series, I want to just show you. Okay, a series is a one-dimensional labeled array. So the arrays that we are talking about, all of them, they're just one dimension, is called a series. So when it comes to pandas, we are going to say series. We are not going to say NumPy arrays. The NumPy arrays have evolved, it become series in pandas. So for example, 10, 20, 30 list, okay, I give it to, so as you have to install pandas and then import it as PD. That's the convention used everywhere. Okay, if I want to create a series, which is just an array in NumPy, I will give this, then I say PD.series, then I'll give this, okay? Right, another one for another series, you see, I give this series, right? Then I can give an index to the series, okay? So we talk about index and all that stuff in Pandas very soon. And then this is another series, you see, it has different values. 10 different type of data type, 10, 9, 40, and then I've given it a name. See, I'm able to give a name to it, right? So series A, this is the first series, yeah, is here. This is the series 10, 20, 30, 40. What you see here on the right is what we call the left, is what we call the index of the series. So this is index 0, and this is the value over there. This is index 1, and this is the value over there, in that order. But if we create the series without giving it an index like this, we get the default index number from 0, 1 to whatever it is. But we can give a label to the index. That's where in this one, in the second one, we gave it a label. So the label we gave it is A, B, C, D. It's the same thing, we just give it A, B, C. Okay, and then the data type for the series is 64, and this one too is also this is 64. Now the third series, okay, we show you can even give a name to the series. So you use the keyword name, you give it a name, and this series has different data type. You see, the name of the series is my series. It has the default indices, and then because it has different type of data in it, the data type is referred as an object. Okay, so that is series. That is not the most common you are going to be using in Pandas. The most common thing you are going to use is the data frame. It is the power of Pandas. Data frames are like tables. Tables or spreadsheet. If you have a spreadsheet, okay, you have a spreadsheet of data. It has rows and columns. You have rows in the spreadsheet and you have columns. Okay, that representation is what we call the data frame in Pandas. Okay, so I'm targeting something like, so for example, right, let's go here quick and say, hey, let's say, okay, now we want to have some data. Okay, it will have name of student, their age, and their city, right? So I have, for example, I have here, I have name, all right, then here, name, yeah, and I have age, yeah, and then maybe I have city, location, right? Okay, and I say student name, location, yeah. I like to, let me use the drawing here. So K for one student, age is 10, location is US, like this. Then another student B, age is 55, and then Ghana, where they are. Okay, this is what the data frame looks like. The columns are, this is the column name, this is the column, this is the column, and this is the data is inside. So this is also called a table in SQL, but you can look at this as a spreadsheet, a regular spreadsheet. You have the header and then you have the values in it, and that is the data frame in Pandas. Now look at how you can create a data frame. A data frame can be something you read from a file, but you can actually create it with code. So remember, we have learned dictionary, the data type dictionary, where we give a key, okay, and then we provide values. Okay, we give a key, we provide values, we give a key, we provide values. Here the values are list, okay, list of names here, and then age key has list of integers, and the score key has list of those scores. Now if I want to convert this dictionary into a data frame, I will say I'm assigned to this variable df equals pd.dataframe, and I'll just give the data, this data I have here. So that gives me this data frame. It has the name column, the age column, and then the score, and I have the name is coming from the name series here, and then the age is coming from this age, and the score is coming here, and then you have the index. The index that we have from series are also here. So this name column is a series on its own, age column is a series, and score column is a series on its own. Okay, now you see that this is here, and just as we provided an option to save the data in a spread in NumPy, you can save the intent of this data to a file and say df.tocsv. You give the name of the file, okay. Index equals false means that don't save these indexes in the file, just save it like this, okay. So when you run this, it will save import at the top, so import pandas as pd at the top, okay. When you save it, Now I should see a file called data.csv. See this file, and this file will have name, age, score, Alice, and that. It doesn't have the index because we said index equals false. Okay, it will not save the index into it. Okay, that's a quick introduction to Pandas data frame. Okay, now you can read the Pandas data frame from a file, as we just saved that file. So I'm going to read back the file. It's a pd.read.csv. So when you are reading from a CSV, the command to use is read underscore CSV. Then you give the path to the file. Okay, then once you have the file, you can do more things about the file, but the most common function you use is the head method. So it's a df.head. It will display the few rows that are showing. Not by default, when you say df.head, it will it will replace the top 5 columns, top 5 rows that are in your data frame. Okay, so we read it like this directly into the data frame, and then data frame.head will give us the top 5. If there are more than 5, yeah, it will give you top 5 records that are in that particular one. Now this PD have ways to read from SL. So pd.read underscore SL will read the file if the file is in SL. There are with the same PD, we have pd.read SQL also. So you can read data from databases. We will reach there where we are reading from databases. But right now we have a file or the data.csv, and we can read from it directly like this. So if you have any CSV, you can directly read from it by just calling the same function, and the head function will give you a view of what is in there. Okay. So the head, yeah, as I said, the head. Okay, so if I want to see only 2 records from the head, I can just say, hey, just give me 2, only 2 of them. Okay, so by default, if you don't give anything, it will give up to 5. Yeah, 5 is the default. Okay, now this function provide information, big information. The dataframe.info method. It provides information about the columns, if there are the data type they have. You see this information here. See, it gives you every column that is in the data frame. Okay, it gives you every column, and it's telling you what is the non-null count. What are the values in the data frame that are not null? How many values? So in every column, it will give you like 3 non-null, and then it give you the data type for each of the series. So the data type for the name column is 3, data type from age column is int, and data type for the score column is int. Okay, it gives you that. So and then at the data types column here, it tells you there are int data type 2 of them, string column data type 1 of them, and it also give you the usage for this particular data. This will create an in-memory object that holds your data frame. So it consumes space, and this is one of the challenges when you're working with Pandas. When you have a lot of data and you have Pandas, it has to load everything into memory and then work on it. Okay, that's one thing you have to understand. All the data is loaded into memory, so you can know how much memory. This gives you how much memory is consuming when you load it. And you can get statistics for numerical columns on the data, right? Our age column is a numerical column, our score column is a numerical column in a data set. So we can get statistics on them. Counts, how many, the mean, the standard deviation, the mean of the record, the 25 percentile of the data, 50 percentile, and 70, the mass. So all these statistics just available by using df.describe will give you all that information. So quickly you can get all that information. All right, let's go to some interesting stuff. So what about if I want to see only the name column that is in the data frame? That's it. So pdf is a data frame. It's like you put it like remember a dictionary when we are looking for a particular key, we do it like this, then we give the name of that column, the name column we are looking for. So this gives you the name column, Alice, Bob, Charlie. Those are the values that are in there, and then the name of, as it's a series, each of the columns in the data frame is a series. The name is the name of that series, and then the data type for that particular, the values that are in that series is a string. You can select multiple of them. Okay, like we can select the name and the score, just the name and the score. So here you see that we have the name here and then we have the score, but we don't have the other value, which is age. Is it the age? Yeah, we don't have the age here. We are selecting only two columns. So here it gives you access to give only two columns. You can see that. Okay. Also, we can select the rows. Okay, you can select the rows we want to see in our output. So data frame dot I log index location, I log LOC, the index location. Okay, this is done when we are referring to getting the data by the index. So I told you this is the index. This is the index. Okay, okay, this is the index. So if I say I log, I say I'm looking for the index location for 0. Okay, the index location 0. What is that? That value is what? The name. What is the name? Is Alice? Yeah, the name here. No, no, we are talking. Look at this. Let me print the original data frame. Print. Let me print the original df the head. That way we can see the data frame here. Okay. Oh. One thing is, if you say df dot head, it prints the result. If you say another print, it will override that. So you have to be careful with that. So let's say, so if you want to do df dot head, you do df dot head, and then let's say I want to print some value. That will give me the value. If I print something after this, it will be overwritten, so I can't see, and I can't see the value there. So if I want to say, okay, so here, all right, I'm printing the data at index location 0. So this is the name is Alice, the age is 25, and the score is 85. So that is what we are seeing here. You see this? The name, age, the score, and then the name. Name Alice, age 25, score this. So ilog is you are going to retrieve the data based on index. Okay. Now I will show you another way, because you see these indices. Yeah, you know the indices, so you can use the ilog to get the data based at that index. But look at this. We have the data from our CSV. We read the CSV. Okay, we can, after we read the CSV, let me show it like this. So we read the CSV, we see the head, right? See the CSV, we see the head, we see everything here. Now the index is just the default index 0, 1, 2. If I want to use a column that is in this data frame as the index, for example, I want to use the name Alice, so that Alice, Bob, and Charlie will become the index for this data set. Then I'll have only the age and score as the columns. Okay, so the function to set the index is called set index, set underscore index. Okay, then you specify the column you are using, like I'm using name column at the index. Now in place equals true means that update this data frame that I'm doing now. There are two ways you can do it. You can say df2 equals df dot set index name. Okay, so this will create a new data frame. Okay, but if I just want to, let's look at it. So I want to print df, okay, df2, print df2 here. So the new df2, okay, df2. So this df2, because now I set the index with the name, you see that the name column becomes the index. Okay, but df, the original df is not changed. So if I say print, let's take this off. And then let's say I want to print the original df. If I print the original df, it's not changed. It's still the same. Okay, the index is not changed to name. So if I want to make it so that I write one code and update the original data frame, that's where you will say you specify the name of the data frame, that I want to set the index for, and then the column I'm going to use, then I'll say in place equals true, means set the index and update this data frame. And if I do that, you see now df now have been updated. Alice is here, Bob is here, and Charlie is here. And these are the columns, right? Now, once I have the index labels, so you see that now I have labels, okay? If I want to get a particular row, I can refer to the label here. But these are labels, they are not indexes, these are labels. So if I want to refer to the data frame by the labels here, I use log, the location, not ilog, okay? Okay, I use NOC, not ilog, because I'm going to use the label. Then I'm going to specify the label that I'm referring to. So I want to look for the row labeled by Alice. So when I gave it, it gave me age, 25 here, and then score 85. Okay, so that's how you can get the locations. Okay, all right, let's go to filtering data set. Okay, you can filter the data set. What's it? We can filter the, so print let's say df dot head. Okay, we have the data frame here. Okay, now let's take this. Now, what I want to show you is this. So we have the df dot head. This is the data set. What about if I want to show only people who are older than 25 years old? Okay, 28 years old. I want to see people in this result. I want to see only people who are 28, the age. Okay, the age is 25. Let's go back and reset the data frame so that we have the original data frame. I want to work on the original data frame. So let me just read it back. Which is just read it back like read the file. Don't set it. Okay, let me read it back. So we have everything back originally without changing the columns. Okay, so I have originally back. Okay, so now what I'm trying to do is this. I want to, okay, this is the original data frame. I want to, let's print it out. This is the original data frame. You have name, you have age, you have score. What I want to do is I want to only get people who are, I want to see only people who are greater than 28 years old. Okay, so now this is how we are going to do that. Okay, you are going to create a mask. Remember we talked about mask in NumPy. So the mask is this. The mask is what is inside. Okay, I say data frame, df for the data frame, then the color I am trying to use, which is the column is age. Okay, column is age, and I say it's greater than 20. That is the mask. Okay, then I apply that mask to the into the data frame here, the original data frame. This one generates the mask, and then I apply the mask to the original, the data frame itself. That is df outside. So you see there's two use of the df is here, creating the mask is inside here. You created the mask. Which mask? This mask also means that it will go through and see each row which is true, false, and create the mask. And now the mask is now applied to the entire data frame. So when it's applied, what happened now? It will only give the values. It will only now give the values where the age is greater than 28. So here you see age 10, 35. Those are the ones that are greater than 25. From the original data frame, if you look at it, when you say the original one, you say df.head. You see, we have more than that record, right? We have more than only two. You see, if you look at this 25 did not show up because 25, the age is, that is not greater than 28. So the mask allows you to get only the record that you need. So for data frames, you have to know how to filter the data, and by creating the mask corresponding to the data you need, and you get that data, then you can apply or anything that you want to apply to only that data set. So the mask is just like we have in NumPy, that extends to how to use it also in data frame. Okay, data frames, you can also sort the values. You can sort the data frame by the values. So right now we have our data frame which has, you know, age, score, and something like that. We can sort it by name, by the age, by the score, and it has the function. So it's data frame df dot sort values. That's the method. And then by will give what column in the data frame you want to sort it by. That's all that means. That's the column. And now the order in which you are going to sort it, ascending equals first. Ascending equals first means that it's going to be descending. It's going to be from highest value to lowest value. If you want it to be lowest to biggest, then the ascending equals true. But if you say ascending equals 4, it means it's going to be the highest value of the score. The person with the highest score will come first, then the person follow will come. So if we run that, that's where now we see this data frame. We have the highest score showing first, then followed by the second, and then the third. So sorting is how you can sort record. Okay, you can sort by one column in the data frame, or you can sort by multiple columns. Okay, if you sorting by multiple columns, you just give the column the order you want it to be sorted. Okay, so take age and then take score. It means that I want to score by age, then I want to score by age, and then I want to sort by score, and then you specify how you want to sort each of the column. So age ascending true. It means I'm going to do age ascending true. Ascending means that the smallest person will come first, and then the oldest person will go, and then like that. So it's ascending true. It will be ascending, and then after ascending the ages, okay, after sorting it by the that order, then I'm going to sort by score. Okay, so score ascending first. It means that if the same people have the same age, okay, because I sorted by age already. Okay, now I go to the score column. Okay, if I'm about to put the age for each of the people with that age, if two people okay, have the same age, the same score, I will have the person with the highest score come first before the one with the smallest score. So you see that this frame ages, okay, but the scores, I want the highest one first, okay, but I'm going to sort everybody from smallest age to the lowest. So this is the meaning of this sorting. Okay, you specify the multiple columns you want, and then the order in which you want to sort it. All right, so we have gone through the basics of the most of this. Then the next chapter is how can we clean data when we have it in Pandas. So okay, we have the data frame. Okay, let's look at a data frame that have missing values or duplicate, something like that. So here we are using both NumPy and then Pandas, because these libraries they work together. So this is a dirty data. Okay, this is a dictionary. I'm calling the data the dirty data. It has name Alice, Bob, Charlie, Bob, and then the last name is 9. It doesn't have a value, right? We're trying to create a dirty data. And then age, this is Alice 25, and then Bob, his name mp.num means okay, none, not a number. That's how you create not a number in with Pandas, none mp.num, and then these ones have values. And then scores, we have this and the mp.num. Okay, all right. Now if we look at this data set that we have now, okay, so it's like this: name, age, score. Alice 25, this. Bob, the age is not a number. Charlie 35, the score is not a number. Bob this, and then here even Alice, this name, the fourth one, the name is not even known. So you see, this is dirty data, and you want to be able to clean this data before you put it into any machine learning or any data analysis. So the first thing is to clean the data, and then you use it. So how do we clean data? Clean the data. These are the functions that Pandas provide. Okay, it's null, not null. You want to determine the missing values that are in there. Drop NA is you use it to remove NA. Any row that has NA, it will remove it. And then fill NA. Fill NA is to replace anything that is NA or none or none. Replace it with a specified value. So those are the important libraries. So for example, for our dirty data frame, we want to say mp the data frame dot is null. Okay, so it will go through the entire data frame columns. Okay, age, name, age, score, and check to see if the value is null. So we create this mask. So the mask is creating, these things create a mask and you can apply it to things, okay? So the first row, name false, false, false. The second row, age was none, so it's true. So basically this function just give you the, whatever the value is now, it will give you true, okay, for that particular location for the value, okay? The other opposite is null, it's not null, you know, but it's null is enough for you, okay? Now, because of if I want to remove rows with missing values, means that if there's any missing value in the row, I'm removing the row. So if I say remove, if I say dirty, data frame dirty dot drop NA, because this one value is true, is null, is going to drop it. And this one to one value is true, so it's going, one value is null, so it's going to drop it. And this one to one value is null, so it's going to drop it. So look at it. If I run this, see what happened? You see that now we have only rows that everything is false, everything is false. Row 0 and 3. See, those are the only ones that survive after we say drop any. All right, so if you drop any, everything is gone. So let's go and read our data frame back. Let's the data frame. Let's recreate the data frame. Once you drop it, the values are gone and the data frame become gone. Like there's no data in there. So, but that's how you drop any. So if I drop it, everything will be gone. So it applies to the data frame. The data is removed from the data frame. That's what I mean. So that's why I have to go back and recreate the data frame here. That way I can reuse it for another calculation. So the values are back in again. So let's say, okay, here, okay. So I drop it, I drop the n array, so now I have only these. Okay, but I reload the data frame, so I still have everything back. Okay, now what about if I want to fill in the missing values? Right, but because sometimes you need to just fill it with some averages or some default values. How do you do that? So if I want to fill it with missing values, okay, I say the data frame dot fill NA. Okay, now look at this inside. Okay, this is a dictionary. Okay, it gives you the age, the key, age key. Okay, it says that if anything age is 0, is NA, use the age the data frame age, that series dot mean. It means that the age column, take the age column and find the mean to replace the ones that have value. Use the mean to replace wherever is NA. This is what this means. Okay, so for the age, that is how we are going to fill it. That's what it is. Okay, now for score column, anything that is none or fill it with 0. That's what this means. Okay, and from the name, for the name column, everything that is none, fill it with unknown. And say in place equals true. It means that apply the changes to this data frame, like in place, update the data frame with the changes. So look at this. After we did that, now the data frame is clean. Everything, all the values are now replaced with what we want to fill it up. So that process is normally you are handling missing values. You have different ways, by mean, by 0, by unknown, as we did here. You can use it to do that. Okay, now let's look at something. Now we've handled missing values. There are some times where there are also duplicates in your data frame, and you don't want a duplicate, right? You want to avoid duplicate. So our data frame now is like this. Say Alice 50, 25, Bob. So far we don't have any duplicate, but we will make duplicate, then we apply the change. There's nothing. The row duplicate means that the row is the same as another row. Bob here age is 28, 90. Bob here age is 30 and 90. So we will make Bob, we will change this value very soon for Bob, so that it will be duplicate. And then when we remove duplicate, it will just have only one value. Okay, so now look at this. If you want to detect duplicate, the keyword duplicated, the data frame dot duplicated. So it will take each row and see if there's a duplicate. So currently we don't have no duplicate. Okay, now we are going to do duplicate work by doing an example. We are reviewing duplicate from a data frame, right? So we create a data frame, new data frame. Alice, Bob, the same thing. Yeah, let's create, but let's look at it. Yeah, this is Ben. Okay, so now we see we have Alice 25. Oh, Alice is duplicated now. You see that Alice here is duplicated with the same Alice here. Bob is good. Bob is also duplicated. Charlie, only Charlie is safe now. So now we want to remove the duplicate. Yeah. So if you run the code, if you ask here, df dot duplicate, it's called df dup. That's the name of the reference. Dot duplicated. If you want to print this, it's going to give you what all the rows that are duplicated. So now you see that, yeah, first row, Alice is good. Then a false is duplicated because it's not duplicated. Second row, false. Then the third row, Alice, now it become a duplicate. So the ones that it sees first, this is all good. Second is all good. Then third, true, because Alice is now duplicated. Then Charlie false is not duplicated. Bob, yeah, true. Bob is now duplicated. So it become true for Bob. So yeah, so that's how you can find those are duplicated. So now, but how? Let's now remove the duplicate. So to remove the duplicate, you use the keyword drop duplicate. So there's the data frame dot drop duplicate. Okay, data frame dot drop duplicate. So so after removing the duplicate, then you can see the new data frame. Okay, so we are creating a new data frame equals df duplicate dot drop duplicate. Okay, so now look at it. After that, we have clean data of only one values. Okay, now I want to show you. I want to show you we can update a value in the data frame. How to update? So, for example, this is data frame. This is the new data frame I just created it over here. I created this new data frame. It has A, B, C, and the value is 147. This, okay. If I want to update B, okay, I want to update B column, the row at 1, okay, at column. So we show the meaning. So at A at, okay, A 80, not A at 80. 80 is giving the row number. Okay, so you see that it says the row number, and then this is the column name. CB, this is the column name. Okay, so 100 has been given to the row number 1. Okay, because this is row number 0, and then this is row number 1. Okay, and then the B column is B column, and then what value was there before? It was 5. It's been changed to 100. Okay, that is 80. Okay, this is updating by the label. Row 1, look at this, row 1 column B. So we are updating by the label. Okay, now we can also update by the position. So because we are saying B is a label, right? Okay, so that you use I at. This is at. This one you use I at. So data frame dot I at position 2, row 2, column 0. Okay, so this is 2, 0, 1, 2. Okay, the column 0. So here, so we are on this row, and the column 2 is 0. So when you do that, this will become 99 because we are updating column 0. Okay, here to what? 99. So when you do that, you see a new value for that particular location. So if you are updating by position, you use IA at. But if you have a label, like you want to use the column label, you use AT. Okay, at and the I at for data frame. Okay, that's for data frame. You can do that. Remember for yes, for data frame. So now, what about if I want to update multiple values in the data frame based on a particular condition? For example, right, set all B that is greater than 50 to 0. This column B, all right, this is column B, right? Say if any B value that is greater than 50, set it to 0. Well, currently we don't have any B that is greater. There's no B. Is that B? let's go back to our data frame and see our data frame. Data frame is here. So let's go here. We want to update by condition. Let's look at the data frame here. df, where is the one? df.head here. Let's see the head here, how it looks like. Okay, so we have, okay, this is the, okay. So we want to update all b's that are greater than 5. That's what I want to say. If it's greater than 5, okay, for b that's greater than 5, set that column to 0. Okay, this is what I mean here. Okay, all right. So I'm going to b column. All right. So that's what I said. dfb. Okay, dfb means the b column greater than 5. Okay, greater than 5. That is going to give me, look at, I'm using the location, not ilog. Okay, I'm using location. dfb greater than 5. So it will take each row where b is greater than 5. Okay, take each of the rows. Okay, and look where b is greater than 5. So here, this is b greater than 5, no. Here b greater than 5, no. Here b greater than 5, yes. And it says set column b to 0. Okay, so when we run that, you see that only here is where b is greater than 0. So we set it to 0. So that's how you can set, you do the condition and do and fix it. Okay, what about if you want to just add some value to a particular column? The data frame column C, the C here, we want to add say 10 to it. So you can say, the data frame column C equal to data frame column C plus 10. You just add 10 to it. Okay, so C now has 10 added to all of it. That's how you can quickly get that one done. I'll say also you can use a function, lambda function, to apply a change to a particular column. So like I say this particular A column, right? I want to apply a lambda function. A lambda function is an inline function. Okay, you use the apply keyword. So the data frame, I said data frame A, the data frame column at A equal to, okay, the data frame column at A dot apply. I'm going to take a lambda function. Okay, what I'm going to do is this. I'm going to take whatever value is there. I'm going to multiply it by 2. Yeah, is that what? Yeah, that's, yeah, times 2. Yeah, I'm taking that value, I'm multiplying it by 2. Whatever it is, I'm going to get that value and I'll put it back into whatever is there. So when I do that, you see, it's multiplied for A. A was 1, 2, 3, and now 2, 4, 6. Okay, so that's how you can apply, use apply and lambda functions to perform that work. Okay, you can change the data types for the data for the columns. You see, if column has age, you can convert age to integer, whatever it is. Those are just some things that you can do. So for example, if I have everything fixed, okay, a clean data phase, and I want the age, I want to convert it to what? To an integer is converted, okay, to all of them to be integer. All right. So for example, if this calls, you can convert them to each by just the keyword is as type. Then you specify the particular column you are trying to update, right? And then you say dot as type. Then you specify the new integer or float or whatever column you want to update it to. All right. So there are more data frames, but I think at this time we have actually gone through. You can convert things to lower rename columns. So if I want to convert this every value name here into a lower, I just say specify the column dot str dot lower dot str dot strip, means that I don't want any what's the name, any white space after the name. So this right or whatever to strip it, make sure. So for data cleaning, these are the operations we are going to do. Yeah, you can rename the data frame, like you have score and you want to now call it exam score. You just say the data frame, you rename it. So the data frame dot rename. Then the columns you want to rename. The first one is the column that is in the data frame, and then the second thing is the new value, a new name you want to give to that data frame. So that's where we now have here. You change the score to exam score. So those are some action. Another thing is for example, for currently, if we have the data frame has none, you can say, hey, the score column. This is a direct way. I say the data frame exam score. Anywhere you see zero, replaces mp.nan. It will become nan. You can replace values for the data frame. Okay. And then there is some things that we can do. We can do aggregations. So that's going to be the last part of the lecture to just carry it out. So let's say we have a department. This is basically, this is analysis. Okay, you want to do analysis, or you have a department, sales department, HR, IT. Then we have name, salary, bonus for this information. I can group by one column and calculate the mean. For example, the department, I want to group by the department, and I want to calculate the mean of the salary of people in that department, right? So if you go to a department, every department, it tell you what is the mean salary for that department. This is how you can do analysis, okay? That's grouping by one column. You can also group by one column and calculate multiple aggregations. So you can group the same by department, group by department. Then you use the keyword .add. You see, here we say .mean directly for only one calculation. But if you want to specify multiple columns that you want to do the aggregation for, right? You do the group by the department .add, then put it into the curly bracket. You specify each column and then what type of calculation you want to do for it. So salary, I want to do mean. Bonus, I want to see the sum. So when I run this now give me every department what is the mean of their salary, and then the bonus, what is the total bonus given to that department. Okay, so that's those analysis can be done easily, and you can group by multiple columns. It's not just what you see. We can group by. So look at this new data frame. It has sales, department, gender, and salary. Right now, I want to group by multiple columns. So I'll say group by. You see dot group by, and I specify the columns. So I want to group by the department and the gender. Okay, I want to group by the department and gender. Then I want to find the salary mean by gender. Okay, so what is the mean salary for men in IT? What is the mean salary for females in IT? So this kind of logic will give you that data. So that's the power here of Pandas, right? So it gave you HR. Okay, there are male. The mean salary is this, and then it gives you there's no male in the HR so far. They give you the IT, it has females and they're making this amount, and they give you the male and they are making this amount. And in sales, the females, their mean is this, and then the male is this. So this is good for you to quickly get this one. And you know, this aggregation function, there are so many of them, so you can get the count, the number of items that are there, like number of people in the IT department. You can get the mean salary, the mass salary, the sum. So all these are available. You can use it. Okay. Now, the last part is okay. What we want to do is we will not go more deeper into this, but I want to say that if you have two data frames, this is a first data frame, and then another data frame 1 and data frame 2. Okay, key and value data frame 2. I can join them together to have a new data frame. This is default. We call it inner join. Is the default for when you join them. So to join them, you use merge. Okay. So pd dot merge the first data frame, the second data frame on is the column on which you are going to merge them on. So these two data frames, they have a key, a value, a key and a value, and I say I'm going to merge them on the key column. So if the key columns are the same, I'm going to merge them. How is inner? Inner means that they have to match in order to be in the new data set. If they don't match, they will not be in the new data set. So if the keys match, so key here A, B, if the key, and then they have here A, B, C, A, B, D. So only A, B matches in both of them. So we have a new data frame that has that. So that is what we call inner join. This is the same also in SQL, which we'll be getting into later on. That is very important to know how that works. Okay. Then we have inner join. This is the default join. Then we have left join. So we just go into this quickly. Not important to understand all of it. We can do that in the class to clarify if there's any issue. Data frame 1, data frame 2, all the same equals key, and then how is left. Okay, left means that the data frame on the left is the first one, the right is the second one. Data frame on the left. How means that if I say left join, I am going to keep everything that is in the left data frame, the first data frame, and try to match the key from the second data frame, their values on it. If it matches, I'm going to bring that value into the new data frame. If it doesn't match, I'll put none, NA, okay, none, like this. Okay, so all the keys from the first data frame will come, and then all the values from the first data frame. Then the values from the second data frame, this one is going to be, okay, if you match, I'll give you your value. If you match, I'll give you your money. If it doesn't match, I'll say none. Okay, that's left join. Right join is the opposite. Now we are going to take the one on the right as the main one, and then we will try to join it with the one on the first one. So you see that, okay, the first one ABD is the right data frame, and then the second one DF1 we get each values, and if it is none, we say none. Okay, that's right. Outer join, on the other hand, is where you take the first DF, okay, and you try to join everything that it has on the other one, and then take the DF and try to join everything and put none where they don't have any match. Okay, so we take A, B, C, D. Okay, these are all the keys. Value 1, wherever there are values for that data frame, we will put the value from them. If there's no value, we will put none for it. Okay. All right. Now, after doing all these things to your data frame, you can then save the data frame, just like saying, oh, okay, df.rename.tsv. The rename .t to underscore CSV, then the name of the CSV. Index equals false means do not store it with index. Okay, so that is what it means to get this one done. And I'll be sending a small quiz to the class to perform on this data frame. And that is the end of this lecture, and thank you for listening.